The investigation was kind of
That's right.
Yep. All right, so if you want a heading, this is like 3C, not 3, we're in chapter 1. 1C.2. So this is for C.2. One thing that I hope you guys noticed through the investigation is that when we have it in this form, and you don't really need to write this down, this guy is kind of nice. We can take the vertex out right away. We can plug in 0 and get that. Intercept is kind of nice. Because if I have this, all of a sudden, don't need to write this down, I've got to do something like this to figure out what the axis of symmetry is and all this other business I got to solve for the intercepts. A lot more work, in my opinion. And maybe you like it, so not trying to diss it, but I'm just saying this is nice. So what we can do is we can take this one, when it's the ax squared plus bx plus c, and make it look like this. Not this stuff, but good question. C2. It's still quadratic functions. You could say quadratic functions using complete the square if you want. So do you guys remember complete the square when we had to find c and add it to both sides to keep it all equal? Right? Can I get some nods if you remember complete the square, adding the same thing to both sides? Well, with this one, we're going to be working all on the same side. So instead of adding something to both sides, we actually have to add it and subtract it to keep it equal. So this is what this will look like. I'm going to have y equals x squared minus 6x plus blank minus blank plus that 5. Yeah, that's what we want. Like, we want it so that I'm only adding 0 to it because it cancels out, right? I'm not changing the value by adding nothing to it because it would cancel out. Watch me work. Okay? just watch me work. We'll get there. So remember that c equals b divided by 2 squared. So remember that's from complete the square. So we will find b same way. So my c is going to be negative 6 divided by 2 squared. So that's negative 3 squared, which is 9. And remember, that is what I put in the 2 blanks. I don't want to rush it, so are we okay so far?
Hold on.
Like there's always going to be the 2 blanks.
I use the blanks to help me keep track of everything. We want to keep it even. We don't just want to add 9. If I just add 9, I change the value. This kind of like Annalise was saying, I'm not really adding anything because it would cancel out. Because it would equal 0.
So this is different than the square that we learned before.
It's so similar though. Watch me finish it. But it's different but very similar. Nina. Yes, you will see in moments. Probably a minute or 2. Okay? So what we are going to do is we're going to take this piece, just the first 3 terms. And if you remember what we did on the left side of our equal sign, remember what we did on our left side of our equal sign is we wrote it like this, the square. We're going to do that. So it's x minus 3. So keep in mind, this number right here is always what goes in here. And then we will simplify this. Negative 9 plus 5 is minus 4. So it looks like the green equation. There's no a is just 1. But
Oh my god.
look at how cute that is.
How do you know?
Pretty cute.
It's just cute for graphing, that's all. Yeah?
Will there any be like any kind of equation that we actually get?
And then the next one.
Oh, okay. I don't like they're not.
Okay. We're going to try one more.
Okay.
But are there any questions? So we are going to do one that does not have a 1 right here. We're going to do one that's a little bit harder to kind of see what that looks like on the next one.
Gotta complete the square.
It's fun.
I have no idea what I'm explaining to you.
All right, so here we go. It's a little bit trickier because I do have a 2 in front. if you recall from last week, Thursday, when we talked about completing the square, we have to divide that out. But I can't just like drop it, I can't just disappear it, because I know that this 2 changes the shape of my graph. I know that 2 tells me it's going to be a little bit narrower. So what I'm going to do, when I divide it out, I'm just going to put everything else in like brackets here. So I'm going to kind of take it slow. I'm going to divide it all by 2 so that, here I'll just go like that. So I have x squared minus 4x plus 3 halves. I'm just kind of taking it step by step here. We're going to do nothing with the 2 for a while. At the very end, we'll distribute that 2 back through, but for now we're going to somewhat ignore it.
Wait, how did you get the 2 on the outside of the bracket?
I divided it out. I factored it out, essentially.
Oh.
I factored it, so it's still there, but it's just this is not the nicest. So it's weird to say that it's factored, but it is. So now I'm just, again, going to leave the 2 there, and I'm going to put my blanks in and figure out what goes in the blanks. So plus and minus. And then see if you guys can figure out what goes in those blanks. Hoping you got 4 in both of those. So now I can, once again, take that part and make it into that binomial squared. So it's going to be x minus 2 squared. Remember, this minus 2 is coming from up here. And I'm going to be honest, I'm going to grab a calculator for that last part. Yes, I probably could do it, but exactly. We've got bigger fish to fry.
I got negative 9.
Yep. And so everyone's all clear on how we got the last number?
Where did you get the negative 5?
I just added this up. That what I just circled?
So you don't. Okay, never mind.
The last thing to do is distribute that 2 through. So I have to take the 2, times it to my first term. This whole thing is my first term. And times it to my second term. So I end up with 2 times x minus 2 squared. And this really nice thing happens when I do 2 times 5 over 2. It's just going to be 5. And you might not be as excited about this as I am, and that's completely fine. I personally think it's one of the better reasons to know how to complete the square, because I like graphing that way better, but that might not be your style. It's just something that you should know. You're going to have 3 problems on this stuff to practice, okay? So we got to talk a little bit about C3, which will be very, very short. Are there any questions here? Okay. So I'm going to talk about this. It is in your textbook, and you can write it down if you want. But do you guys remember when we talked about the discriminant being b squared minus 4ac? And we talked about the 3 situations. I'm going to go through all that. But the 3 situations are when it was equal to 0, greater than 0, and less than 0, right? Positive, negative, and equal to 0. So everything is pretty much true when it comes to graphing. So I'm going to graph a little example of all of these. So if your discriminant is less than 0 or negative, that means it does not touch the x-axis. Remember, if it's negative, there's no solution, right? So it doesn't touch at all. So maybe your graph looks something like this. Doesn't touch at all. No solutions. If it equals 0, there was one solution, right? So it's going to touch the graph just one time. Maybe it looks something like this. So that would be just one solution, touching just once. If it is positive or greater than 0, positive. Remember, when it was positive, there were two solutions. So it touches the x-axis twice, or crosses or cuts. So maybe it looks something like that. And it's got two solutions. So you just have a few problems on your assignment where you calculate the discriminant and then you tell what would happen with the graph. If you get 0, you say it touches once. If you get a negative number, you say it's not going to touch the x-axis. If you get a positive number, you're going to say it crosses the x-axis twice. So that's all you're going to have to do is kind of transfer that discriminant knowledge and apply it to what the graph would look like. So I'm going to wait a moment because I know we still have some people writing stuff down, but that is going to be it for now. Sweet. Now, you guys probably wrote down C1 yesterday, so then all you would have to write down is C2 and C3. So I just circled that.
So it's the first part of the bottom.